Hi guys, Mike here from Comp3 Interactive. Welcome back to the channel. Today marks the start of a new mini-series where I'm going to show you how to make a fully customizable FPS controller. Now the reason for this is I actually have in my mind a few ideas for first-person games that I want to do tutorials on. So instead of repeating myself for each one of those series, I thought I'll do this one first, and then I'll just use it as a callback for any future first-person game that I do a tutorial on. So I'm going to split this out into multiple different videos. The first one, this one, is going to just be the base foundations for keyboard inputs and mouse look, and then we'll go into the more detailed things like crouching, jumping, all the way down to interaction and adding the head bob. And what I'm going to try and do, I'm going to try and make it so this is really modular. So we're going to be able to toggle on and off all of these different features dependent on what you need for your games. So I hope you stick around. I hope this is actually going to be useful for you. I know it'll be useful for future tutorials, so it's not going to be completely wasted effort. But before we jump into it, I do want to thank Gigatank3000 for sponsoring this video. I've got his links down in the description below. Go check him out on his website. Go follow him on Twitter. Keep up to date with what he's up to. And I also just want to thank everybody supporting me over on Patreon. You guys are fantastic. Okay, so I've just gone and set up a completely empty project, and I've deleted all these standard Unity assets out of here. All we have left is the directional light and the main camera that comes by default in any scene. Now, the first thing I'm going to do, I'm just going to reset that camera to be in the direct center of our project, so all the zeros. Now, we'll go and we'll create C# script, and we'll call it first person controller. Now we'll open this up in Visual Studio. So what we're going to do, we're going to add in all the variables that we think we're going to need for this step. Then we're going to add in the empty methods, and then we're going to tie all this together. We're going to do one method at a time. So first of all, we're going to want a public property to actually determine whether or not our character is in control, or our player is in control of our character, rather. So that's going to be a public bool can move. We're going to make this a property. So that's going to be a get and then a private set, because we don't want to set this outside of this script. I'm going to default that to true. Next, we'll add in a header attribute just so we can keep this all nice and tidy inside of our inspector. And these are going to be our movement parameters. So for this tutorial, for this episode of it, we're going to add in a walk speed and a gravity multiplier into here. And we're going to do this properly. So I'm not going to make these public. I'm going to make these private, but we still want to be able to amend them inside of the inspector. So the way that we can do that, we add the attribute, serialize field, private float, walk speed, and I'm going to give it the default value of 3. Next, we want our gravity multiplier, so exactly the same, serialize field, private float, gravity, and I'm going to default that to 30. Now we can amend these in the inspector at any time that we want. Next, we want to define our look parameters. So this is going to be the parameters that are controlled via our mouse look. We'll call these look parameters. And we're going to want 4 different ones in here. We're going to want the look speed for the mouse on the x-axis and the y-axis. And we're also going to want an upper and a lower look limit, because on any first-person game, if you drag your mouse up or down, you're blocked at a certain point, because obviously you can't crane your neck all the way back and look behind you upside down. That would just ruin the player's experience. So we want to limit how far our player can look. So again, serialize field, but this time we're going to put a comma and we're going to add a second attribute in here. And this is going to be the range. So inside the inspector, we can limit an upper and a lower number for these. So for our look speeds, more often than not, games have a look speed of between 1 and 10. So we'll just add that in. Now, if we finish this off, private float, look speed X, and I'm just going to default this to 2 for now. And then we need exactly the same again for look speed Y. Now you could keep those both the same if you wanted them linked. I always like having X and Y separate, even if I end up having them the same. That's personal preference for me, but some people just like that extra bit of customizability. Next, we'll just paste that in again, but this time we're going to limit this variable's range to 1 and 180. And what this is going to be our upper look limit. And I'm going to set that to 80. So that's going to be how many degrees we can actually look directly up before the camera will stop moving. And then we'll copy that, call that lower look limit as well. So that's going to be it for the variables that we can mess about with in the inspector, but we do still need a few private reference variables inside of our script. So these are just going to be private. We're not going to mark these as serializable. And we're going to need a reference to the camera. Call that player camera. And we're also going to be using the character controller. Call that character controller. So we need a reference to our camera so we can rotate it, and we also need a reference to our character controller that will be attached to this game object so we can actually move our character about. Just a few more variables now. We need a private vector3, which is going to be our current move direction, and a private vector2, which is going to be our current input. So our move direction will be the final move amount that we apply to our character controller, and our current input is going to be the value that we're giving to the controller via our keyboard, so either through WASD or your arrow keys. And finally, we need one more private float, and that's going to be our X rotation. And the reason we're going to keep a reference to that is because that is the angle that we're trying to clamp with our upper and lower look limit. So we can keep a reference to that and then use mathf.clamp on that, but we'll get to that very shortly. So let's move on to the methods before we actually start coding this. I'm going to change start to awake, and the first thing we want to do is cache these two components, so our camera and our character controller. And you've seen this done before. We're going to do player camera equals get component in children, because our camera is going to be a child object of our actual first person controller, and inside the angle brackets we're going to put camera. Now this could be done by serializing the components and initializing them yourselves by dragging them into the inspector, but for stuff like this I just like using get component in either start or awake. Next, our character controller is going to equal get component this time, because this is going to be attached to the parent object, and grab that character controller. Nice and simple. Next, we want to lock our cursor, so the cursor is no longer visible and it's locked within our game window. So we can do that by setting cursor.lockState equal to cursor lock mode dot locked. And then we'll go ahead and hide it by setting cursor.visible is equal to false. So we've cached all our components. We can now get working on handling our inputs. So I'm going to wrap my entire update in an if statement, and that's going to be if we can move. So if we take away the ability for the player to control this first person controller, we don't want to actually do any update functions on it. That way we can actually force things like locked perspective cinematics and the such. So inside here, we're going to need three methods. We're going to need to handle our movement input, i.e. keyboard inputs. We're going to need to handle mouse inputs for look, and then we're going to need to apply all of those final movements every frame. So let's create these methods. That'll be a private void handle movement input, if I did all that correctly anyway. There we go. Private void handle mouse look, and private void apply final movements. And we can just call all three of these from inside of our update method, remembering to put apply final movements at the end for obvious reasons. So let's start with our handle movement input. So this is going to be our keyboard controller. So the first thing we need to do is actually calculate the direction on a vector 2 of our player's input multiplied by the speed in which we want to move. So the way that we can do that, we've already defined our current input vector 2 variable. We can set current input equal to a new vector 2, and this is going to be our walk speed multiplied by input.getAxis, and then in parentheses we write a string of vertical being the W and S key or the up and down arrow. So that's going to grab our forward and backward movement, but we also want our side movements as well, so A and D or left and right. So again, we'll just multiply walk speed by input.getAxis, and this time we're going to pass in horizontal. So So that's going to get our left and right movements. The next thing we've got to do is we've got to cache temporarily our direction on the y-axis, so the actual vertical going upwards away from the floor or going towards the floor. And the reason we've got to do that is because when we update the vector 3 for the position, we want to make sure that we reset that y position back to its original value. So to do that, nice and simple, we'll create a float, move direction y, and we'll just set that equal to move direction dot y. And then we'll use that in just a second. Now we want to actually calculate the move direction, so the vector 3, based on a character's orientation. So we're going to be using transform.transform direction and passing in forwards, or left or right as well, depending on which axis we're working on at that point. So let's just go ahead and do that. So that's going to be move direction will be set equal to, and then in brackets, we'll do player's transform dot transform direction and pass in vector 3 dot forward to get our actual forward axis. And then we want to multiply that by our current input dot x. And then we want to add to that, again, in brackets, transform dot transform direction. And this time we'll just pass in vector 3 dot right and multiply that by our current input dot y. So now we should actually have a vector 3 inside move direction which adheres to our current player's orientation, so whatever direction they're facing in, and then we're going to add together those values and our current input. So if we're facing northwest, for example, and we press W, we're going to move forward along that northwest angle. And then, like I said before, we just need to remember that move direction dot y needs to be set to a cached move direction y. So let's go ahead and save that, go back into Unity, and we can actually set up some of this controller. So what I'm going to do, I'm going to create an empty game object, call it first person controller, center that back to 0, and I'm going to put my main camera as a child of the first person controller. So now that we have our main camera as a child, when we cache get component in children, that's going to grab our camera. Now we need the character controller. Now the character controller goes on our first person controller parent object. So let's add that in. And we already see we're given a capsule collider and quite a few different options down here. Now right now we don't really need to change anything inside of our character controller. What we're going to do though, we're going to grab our main camera and we're going to bring this up slightly, just so it's towards the top of that capsule collider, so we're not viewing the game from the stomach of our player. Now if I just quickly add in a plane for a floor, and then we go over to our first person controller and let's drag our script on. So there we go, we can see we have our walk speed of 3, gravity of 30, and the rest of our look parameters. If I just bring that down slightly. So just like that, we actually have our first person controller base object ready to go. All we need to do is remember to apply all of these movements inside apply final movements. And then once we can see that arrow keys are working, we can get working on the mouse look. So in this one, I wasn't going to do it, but I will apply gravity. Now that won't actually come into use until we do the jump tutorial, but it is good to have it in there. So let's first apply gravity. So if our character is not grounded, so that'll be the exclamation mark, we'll get our character controller and we can call is grounded on that. So if we're not grounded, we're in the sky, we can set move direction.y minus equal to gravity times time.delta time. So that's going to pull us down towards the nearest surface. Next, we'll apply all of those movements that we've calculated inside handle movement input. So to do that, we get a character controller that we've already cached. We can call move, and then inside move, we'll pass our move direction multiplied by time.delta time. So if we save that, hop back over into Unity and hit play, we won't have mouse controls at this point, but we can see our character moves about, and if we walk backwards off this plane, gravity takes over. Nice and simple. All right. let's work on this mouse lock for now then. So this actually isn't that difficult. What we're going to do, we're going to first determine what our y-axis is on our mouse, which is our up and down value. And this is where it may get a little bit confusing, but the mouse y value actually controls the X rotation of the camera. And the reason for that is when you move your mouse up and down, you want to rotate your camera round from a central pivot point. So moving up would rotate along the X-axis to face the camera down or up. So let's start by doing that. So we've already got a local reference to rotation X. And what we're going to do, we're going to minus equal input.getAxis. And this time we're going to pass in mouse space Y. Now remember capitalization on that. You need a capital M, a space, and a capital Y in mouse Y. And then from that, we're going to multiply that by our look speed Y. And again, if you want to keep that look speed as the same value, ignore the Y, just call it look speed and use the same variable for both the X and the Y. So now we have a rotation based on our mouse input. We want to clamp that using our upper and lower look limits, so we can't actually spin the camera around 360 degrees. So again, we're going to set rotation X equal to mathf.clamp. Now here we need three parameters. We need the value that we're trying to clamp, rotation X. We need the minimum value that we're allowing that value to be, which is going to be minus upper look limit. And we need minus because obviously when you rotate out in that direction, you're going to hit 360 and then it's going to go into a minus value. So we're going to set it to minus whatever our value is, so minus 80. I hope this is making sense. And then for our third parameter, we're just going to use our positive lower look limit. So that should clamp our camera to looking at 80 degrees up and 80 degrees down. Next, we'll apply that rotation to our player's camera. So that's going to be player camera dot transform dot local rotation, and we'll set that equal to a new Euler, or Euler. I got shouted at for calling it Euler in one of my other videos. So quaternion dot Euler, passing our rotation X and then zeros on the Y and the Z. So that takes care of our looking up and down. Now we want to be able to look left and right. And for that, we're not going to rotate the camera, we're going to rotate the parent game object itself. So this time we've got transform dot rotation multiplied equals, and we're going to multiply it by quaternion dot Euler, 0 on the X. We're going to use input.getAxis mouse X, multiply that by look speed X, and then 0 on the Z axis. And now, just like that, we should be able to go into our game, walk around, and actually use our mouse to look. And we can. We have smooth movements on our mouse. We can walk to the corners, look around, and you see, if I just go to the edge here, that's my lower look limit, so I can't look past that angle. And then if we look up, we can just see the corner of the sun right there. I can't look up further than that. Simple. Now, if we increase that look limit to 180 and 180, we should see I can go well beyond into a 180 degree angle, which obviously is way too far, but all depends on what kind of game you want. And again, we have the look sensitivity in there, the walk speed, and the gravity multiplier. So I think I'm going to leave it there for this episode. We have a functioning first-person controller at the moment, but in the next video, we're going to start with adding our sprinting functionality, because what is a first-person game if you can't sprint? So I hope that's been useful for you. Make sure you tune in for the next episodes of this, where we're going to keep bolting extra functionality onto it that you can toggle on and off. And just as a heads up, this is going to be the last tutorial series that I'm going to be able to record in this area, because we're moving house soon. So I'm going to try and get all of this series done and recorded, so there shouldn't be any gaps, hopefully, in tutorials while we're doing the move. But the next time you actually see me from a new recording, I should have a decent looking office for a change, so keep an eye out for that. Alright then, I'll see you again next week. Thanks for watching, guys. If you like the content, remember to subscribe to the channel for weekly Unity tutorials.